Welcome back to the next part, 3-6. We just finished this screen right here, and I said we'd come right back to graph. So hopefully you just went through and got this information down, and you've hopefully understand how we got through it. If not, go back and review that video. But now what we need to do is graph it. So we're going to graph here. And recall, we're going to start with the lower boundaries, -2/3. Now, and -6, whoops, I did that backwards, didn't I? Oopsie, because I'm on negatives. All right, that's actually going to be -6. Sorry about that. -2/3 we'll put over here because I'm at negative land. -2/3. And then 0 would be right there, maybe. Okay, so -2/3 is greater than x. Okay, greater than or equal to. So that's a solid dot, right? Solid dot because it's or equal to, but -2/3 is greater than x. Okay, so that means that x has to be over here. Okay, because these are values of x where -2/3 is greater. -2/3 is greater than x. So that means x is actually less than -2/3, which would be this side. And then the other condition is x is greater than -6. So that's an open circle there. But x is greater than, so values greater than go to the right. So if that's an and condition, that means my solution is basically this area right here, where here's x. Okay, I know that x is greater than -6, and I know that -2/3 is less than or equal to -6. So there's my compound inequality, my and inequality there for you. Okay, hopefully that makes sense. If, again, you need some more practice, I'd suggest you go to the page there, 201. As we really just have one more example we need to be doing, then we'll be done. All right, so here we go. Do a dotted line there and go to the very last page. And this is the problem. Solve and graph the compound inequality 3x plus 2 is less than -7, or -4x plus 5 is greater than 1. Okay. Let's recopy it here and then talk it through. Okay, so basically with an or inequality, there's not a shortcut like the and. You have to basically solve an or, what we're talking about here, solve an or inequality. You have to solve them individually, one at a time. Okay, so you have 3x plus 2 is less than -7. So let's just look at that one first. Okay, we're going to subtract 2 from both sides, or add -2. I actually prefer to think in terms of adding -2, which is the same thing as subtracting 2. That cancels out my 0 pair there, and I have 3x. We add, bring your sign down. You don't reverse the sign here, right? You don't reverse it because it is adding to both sides, so -7 plus -2 is -9. We divide that by 3, and we're dividing here, so do we reverse that? That's a negative number. I hope you're saying no, no, no. You don't, because you're dividing by a positive number, so you don't flip the sign here. You end up with x is less than -3. Now, this one over here, if we solve this one, let's add -5 to both sides. Solve that. 1 plus -5, and that would give me -4. Over here I have -4x, because my 0, that zeroed out right there, -4x is less than -4. Divide by -4. Okay, that's 1. Okay, now, do I reverse this sign? I divided both sides by a negative, so yes, you switch that sign. You get +1, you get positive x is greater than 1. So you end up with x is less than -3, or, let me just bring that condition down, or x is greater than 1. Okay, so we solved it individually. Okay, here's another note. Do not reverse. I meant to put this over here a minute ago. This point right here, I've just run into this mistake. You don't reverse the sign at that point, okay? But number 3, you do reverse when you go negative 4x divided by 4, negative 4, sorry, which was this point right here. Okay, we do reverse the sign at that point. And then we're going to graph and start with the boundaries here. So we're going to graph it on the same number line, just like we've been doing. And we're going to graph the 2 boundaries. Okay, so one boundary, x is greater than 1. That's an open circle going this way. And then we have a boundary at negative 3. Again, I like to have 0 in there just for some perspective. X is less than negative 3. Okay, so there's x is less than negative 3, and there's x is greater than 1, right there. So any number down here would be a solution on this side of negative 3, and any number over here on this side of 1 would be a solution as well. So there you go. That's a lot of stuff, compound inequalities. There's a lot of really interesting kind of problems we can solve with these, and we'll be looking at those in the next few days once we've got kind of our head wrapped around on how to create this graph here. So we'll talk.